We have seen L'Hopital's rule to study limits of the form 0 divided by 0 or infinity divided by infinity. If we want to study any of the other strange limits like 0 times infinity or infinity minus infinity, etc., we want to reformulate a given problem of this type as 0 divided by 0 or infinity by the infinity, and then we can apply L'Hopital's rule. So let's do a few examples right here. Limit x goes to infinity, x times e to the minus x. So we could call the function f to be the x, and then the limit is infinity. We could call the other function e to the minus x and study the limit also. And the limit e to the minus x for x to infinity is 0. Okay? So then looking at the original function, this is a problem of the form infinity times 0. The strategy I told you is to bring this into the L'Hopital form so that we can use L'Hopital. How do we do that? Well, we know if we divide by 0, we multiply with infinity. So we have to write this as a ratio. And I do this. So this upper limit there equals limit x goes to infinity. I keep the x. I write the e to the minus x in the denominator as an e to the x. Okay? E to the minus x is the same as 1 over e to the x. Ha! Now let's look at the limits as x goes to infinity. In the numerator we go to infinity, and in the denominator, if x goes to infinity, we also go to infinity. This is an infinity over infinity type. Ha! This means, ta-da, we can apply L'Hopital's rule. So then we write an equal with a little h on top. We keep the limit sign first of all, but now we are allowed to differentiate the numerator and the denominator separately. So if we differentiate on top, we get a 1. If we differentiate in the bottom, we get an e to the x, which then is the same as the limit x goes to infinity of e to the minus x, and we know already that this is equal to 0. Let's do another example. Here we have limit as x goes to 0 from the right, 1 over x minus 1 over sine x. Okay, so the first function f of x, 1 over x, and then the limit as x goes to 0 from the right, 1 over x is equal to, yeah, this goes to infinity, plus infinity. The other function would be the sine, 1 over sine x, and then here the limit as x goes to 0 from the right, 1 over sine of x. Remember, sine is 0, so this also goes to infinity. So then this is of the type infinity minus infinity. Again, this is something we are not allowed to do. Infinity minus infinity. Can be anything. So we again want to write this in a form so that we can apply L'Hopital's rule. And of course this already cries for a common denominator, doesn't it? So let's do that. So the common denominator is x sine x. So then we get a sine x for the first term, a minus x for the second term. Common denominator is x sine x. All right. Now let's look at the type here. On the top, if x goes to 0, we get a 0. On the bottom, as x goes to 0, we also get a 0. So this is a 0 divided by 0 type. And ta-da-ta-da! Again, we can apply L'Hopital's rule. Equal with a little h on top, limit x goes to 0. And so now we differentiate the top, which is cosine of x minus 1. And then we differentiate on the bottom. And then we need a product rule. So we differentiate x first, then we keep the sine. Then we keep the x. We differentiate sine, which is cosine. And let's look at the type here. So now on top, as x goes to 0, the cosine goes to 1. 1 minus 1 is 0. All right. In the bottom, the sine term goes to 0. And the x cos x term also goes to 0. So this is a 0 divided by 0 type. Oops. So we don't have a result yet. But, ta-da, we can again apply L'Hopital. Okay, so why not? Let's apply it once more. Okay, limit x goes to 0. So we differentiate the cosine, which is minus sine. Differentiating the 1 is 0. Derivative of sine is cos. And then differentiating x cos x, we have a product rule. So we get plus cos x and then minus x sine x. Right? The derivative of cos is minus sine. So we get a minus. Okay, let's see what type it is now. Maybe we have to do L'Hopital again. Who knows? So the top is 0. And then if I take the limit in the bottom, I get a 1 from the cosine, another 1 from the second cosine, and then a 0 from the sine terms. Oh, okay, so this is wonderful. This is equal to 0 divided by 2, which then, of course, is 0. So you see we had to apply L'Hopital twice to get to a result. And it can easily happen that you apply it even more if need be. So don't give up so easily. And then here a final example of x to the 1 over x. Again, I do this carefully. I write f to be x, and then the limit as x goes to infinity, this is infinity. And the exponent I call g, 1 over x, and this limit as x goes to infinity, 1 over x is of course 0. So then this is of the type, what do we have? Infinity to the power of 0. This is now very strange, isn't it? You know, a finite number to the power of 0 is always 1. But now we have an infinite to the power of 0. So who can help us? Of course, L'Hopital will help us, in this case, too. So here I need to reformulate this again so that I get a fraction. And I use the rule for the exponents and logarithms. So I write this as e to the ln of x to the 1 over x. So you might remember, right, that e to the ln a is a. So that's what I used, one of the exponential rules. Now I can write this to be a limit x to infinity e to the, and now the exponent comes to the front. So this is 1 over x ln x, which I then write to be a limit x goes to infinity e to the ln x divided by x. And now the limit is only in the exponent, so I can carry the limit into the exponent. So then we get e to the limit x to infinity log x divided by x. Now we have a wonderful ratio and we can look at the type. So logarithm goes to infinity, x goes to infinity, so that's the type infinity divided by infinity. Actually, it's a limit we computed already in the previous video. Okay, nevertheless, so let's do the L'Hopital now. Limit x goes to infinity. Differentiate log, we get 1 over x. Differentiate x, we get 1. So we keep 1 over x in the exponent, which then goes to 0. So this goes to e to the 0, and e to the 0 is equal to 1. Okay, so here's L'Hopital's rule again. And whatever we try to do, if we try these strange limits, we always go back to this case, to one of these cases, 0 over 0, or infinity over infinity, and then we apply L'Hopital's rule.